Hello everyone, welcome to our next section. So the main topics of this section will be ADC, which is analog to digital conversion, and we'll be talking about a few sensors and actually seeing how analog signals can be used upon with the Arduino Uno board. We'll also be talking a bit about the PWM feature that I talked about in the overview of Arduino Uno board. So basically PWM stands for pulse width modulation, and we'll be using this feature on the Arduino Uno board to turn the brightness of an LED. We'll be controlling it, and so first of all, let's get started with today's lecture. So today we'll be actually covering what ADC programming is and what is analog to digital conversion, as well as a bit about sensors, and we'll be also interfacing a potentiometer, which is basically a 3-pin resistor, and it can give varying voltage to the Arduino Uno. And we'll be interfacing this potentiometer with the Arduino Uno board and writing the code, learning a few more functions, and at the same time performing simulations in Tinkercad. So without further ado, let's get started. So first of all, I would like to touch upon what is exactly a sensor. So basically, sensors are extremely important components of electronic systems which allow the microcontroller to get information about various physical quantities in electrical form. So you can say that sensor is a device which converts non-electrical quantities into electrical quantities. So microcontroller based systems like Arduino have the ability to process both analog as well as digital signals. For this purpose, Arduino has something called an ADC module, which is basically an analog to digital converter module which does the job, which basically means that there is no need of any external chip to perform this task. Moreover, Arduino Uno has 6 channels for this analog signals, which are from A0 to A5, which we also touched upon in the overview of Arduino Uno board. So what they do is basically when you connect any sensor to them, the sensor sends data in the form of basically any voltage between 0 to 5 volt, and what the Arduino Uno does is that it converts it into a value between 0 to 1023, and you can display this on a serial monitor or maybe use it for another task. So basically, a potential which you can see on your screen right now has 3 pins: the VCC, the ground, and the output pin, which will be connecting to the analog channel of the Arduino Uno. And it is basically used as a variable resistor in various electronic circuits, and that is how we'll be using it. So now when we get to the code part, we'll be actually using a new function called analog read, which will basically convert all the analog output signals sent by the potentiometer to its equivalent integer value, and we'll be printing that on the serial monitor. So here is a rather straightforward circuit diagram of the potentiometer interfaced with the Arduino Uno. So as you can see, the red wire indicates the VCC, which is connected to the 5 volt pin on the board, and the black wire is connected to the ground, and the blue wire is actually the signal wire which we have connected to the analog channel A5. So using the analog read function, what we'll be doing is, just to repeat this, we'll be actually converting the voltage that is sent by this potentiometer into its equivalent integer value on a scale of 0 to 1023, and printing that on the serial monitor. As we have been moving in a very systematic way, let's actually see the flowchart of the code and really try to imbibe the logic. So let's get started with that. So as you can see right now, I have the flowchart of the code in front of me. So in the setup function, we're of course initializing serial communication at 9600 baud rate, which we just learned about in our previous lecture, in the previous section. So why are we doing this? We're doing it so that we can print the value, the integer value that we're looking for on the serial monitor. So in the loop function, we'll be actually reading what is the output being sent by the potentiometer that is connected to the analog channel. So, and then what we're going to do, we're going to use a variable to store the equivalent integer value. So all the ADC, which is the analog to digital conversion, is being done by the onboard chip. So all we have to do is create a variable and just store what is being read by the analog read function. Then we're going to send that variable, which we're going to name as sensor value, and send it to the serial port, which means that we'll just print it to the serial monitor. And we'll also be giving a delay of 1 second so that we have better readings. So I guess the flowchart is pretty much clear now. So let's actually go to Tinkercad, write this code down and simulate it. So here we are in Tinkercad. So let's just quickly make our circuit. So we need an Arduino, of course. We'll be also needing a potentiometer. So I'll just quickly search for that, and here it is. So I'll be setting the resistance as 10 kilo ohm. And now let's actually make all the connections. So the terminal 1, which is the VCC, will go to 5 volt, and terminal 2 will be actually the ground. So let's just change the colors as well. Make ground is black and 5 volts is red. We will also use our middle as the output, which will be sending the output basically the Arduino Uno board, and we'll be connecting that to A5 and making this wire perhaps blue. So this is what our circuit will be looking like. So now let's get to the code section. So I'll be going through the text code as well as the block code. So let's start with the text code first. Here I am in text. So first of all, what we'll be doing is, according to our flowchart, we'll be initializing serial communication. So with that out of the way, serial dot begin 9600, the baud rate, and we'll also be creating a variable called int sensor value. So it will be int sensor value. So we've created the variable. Now in the loop section, as we discussed before, we'll be using the analog read function and storing the value in this variable. So let's do that. Sensor value is equal to analog read. Note that the R here will be capital, and we've connected to the A5, which means the 5th port, which is technically the 6th. So we'll be writing A5 here and adding a semicolon. Next, what we'll be doing is we're actually going to print this value. So we are going to write serial dot print ln, in the brackets we're going to write sensor value. We're also going to give a delay for better performance of the simulation. So delay 1000. So this is majorly what our code will look like, and we'll be adding a semicolon here. So this is majorly what our code will be looking like, and let's actually start the simulation. So now the simulation is started, and I'll be making my way to the serial monitor, and as you can see, it's printing 1023, which is the maximum value as of now. And as I decrease by using this potentiometer, you see how the value is decreasing all the way till 0, and as I increase, the value increases all the way till 1023. So a potentiometer is used in various sensor modules that we'll be discussing. So in light sensors, in the PIR sensor, which is a distance calculating sensor, we actually have the potentiometer there. We also have it in the infrared sensor module. Moreover, when we're using LCDs, it has a vital role over there, and it helps to control the brightness of the LCD. So let's get started with the blocks code as well. Let's actually take a look how the block code will be written. So let me just put this first of all in the bin. So as we did before as well, we'll be creating a variable. So let's create a variable over here. Let's name it as sensor value. So in blocks, we do not need to initialize serial communication. So all we need to do is that we need to set the sensor value to our analog read A5. So I'll be going here on the input section and read analog pin. So I'll be placing this here and saying A5, which is the pin where the potentiometer is connected. And next, I'll be printing this on a serial monitor. So in order to do that, I'll be using this function over here, print serial monitor, instead of hello world, I'll be actually using a variable. So making our way back to variables, we have sensor value, and I'll be adding this over here. So now this looks good. Let's actually start a simulation once again. Now that our simulation is started, we'll be making our way to the serial monitor. And as we actually turn the potentiometer, the value of the voltage that we're getting, and successively the value of the equivalent integer that we're getting on a serial monitor changes. So we're also going to talk about another feature where instead of the serial monitor, we'll be printing the data on the serial plotter. So what does the serial plotter do? It basically prints a graph of the data that is being given to the Arduino Uno using the potentiometer. Let's just start the simulation once again, and over here we have the serial plotter. So this is what the data looks like. You're noticing how if it's 511 right now, we're getting a value of 511 over here. Just perhaps increase this a bit, and as we decrease, we're actually getting a graph where the value is being decreased with negative slope, and as we increase the value, we get a graph with positive slope where the value is increasing. So this is how we actually print data to the serial port, and we can view it in the serial monitor or the serial plotter. So with this, we come to the end of our potentiometer interfacing and the basics of ADC programming.